Okay, we're solving each equation for x, and there's something interesting that's going on here, just worth looking at. It appears that there's two different x's, and how do we get them by themselves if there's two? Well, we would love to be able to combine them somehow. So I'm just going to make a little note up here, and then I'm going to erase it. Um, I'll do it in red. If this said 5x plus 2x, what would we do? Oops, there you go. What would we do? Well, we would take the coefficients and we would add them and say that's what it's equal to, okay? You could say 5x plus 2x is 7x, or another way that you could say it is 5x plus 2x, and I'm going to erase it so I can write it there. 5x plus 2x is 5 plus 2x, right? Just adding them together for the coefficient, but I didn't actually combine them yet. That's essentially what you can think of this as. Now, what did we do here? Well, the effect of this is that we kind of factored the x out of both of them, okay? So that's what we're actually going to do. We're going to factor the x out of both of them. This is kind of a special one. It's not special. It's just you need to know you need to know how to think about it, okay? But what we're going to do is we're going to factor the x out of both of them. Since they both are m and n are being multiplied by x, we can say, okay, well, let's pull that x out front. Hold on a second. Okay. Let's pull that x out front and say it is x times m plus n. And again, if you were to think about it, you could say, if you distributed this back through, x times m, mx, x times n, nx. Okay, so now that we factored that out front, we say, okay, well, that means that x is being multiplied by the sum of m plus n. So how do we undo that? We divide by the sum m plus n on both sides. This will cancel out, and that leaves us just, oops, x on the left side, and p equals m plus n. Okay, that's the answer. That's what they asked you to do. Okay. Now I'm going to do a proof on this because I want you to see that it definitely works, and I want you to see what the proofs look like when you do them on these types of problems. Okay. Are you required to do it? Well, according to this problem, it doesn't say so, but I think that you should get in the habit of doing it. It's going to make you so much stronger in math. This is truly going to make you a lot stronger in math. And you say, but Mr. Massey, you don't require it, right? So I don't have to do it, right? Well, that's one way to look at it. You can do the bare minimum, but try it out because just like any of the other problems, doing the proofs shows you whether it works or not, whether your answer was true. So watch what we do. Take the proof. We write the original equation. And now we say, wherever there was an x, we plug that in. P over m plus n. Okay? And now we're going to multiply this through. M times this is mp over m plus n, and n times this is np over m plus n. Yep, equals p. Now, since they're both over the same denominator, we can combine them, okay? And that's just like saying, like if you had something like 2/7 plus 3/7, you could say that's the same as 2 plus 3 all over 7, which will eventually be 5 over 7, right? So if two things have the same denominator, you can just write this plus this all over m plus n. So I'm going to do that right here, okay? And then notice, just like we did in the original way of isolating, oops, something funny is happening here. That's better. Sorry about that. Just like in the original problem over here, where we said they both have x, we're going to factor x out. That's what we see up top. We see both these things have p, and so we're going to factor that out front, okay, on the top. We're going to just take the numerator, and we're going to simply rewrite the numerator with the p multiplying m plus n on the top, okay? And that's all over m plus n. Yep. And what can we cancel? We can cancel m plus n top and bottom. And what are we left with then? We are left with p on the left side equals p on the right-hand side. If you do this correctly, you will come out to have the same thing left and right, which we know will be a true statement, okay? So that's the proof of it, and I'm going to give it a check because, hey, that worked out. Yep. I do suggest that you do these proofs, whether you, I'm not going to require them, and this becomes one of those cases of the kids that do it, you're going to be great. You're going to be good at this by the end of the year. You're going to be rocking 90s on your tests and things like this because you're not just doing the bare minimum. The rest of the kids, you're going to be struggling for the additional points that you need, possibly, to pass the class or to score what you need, okay? Because the goal of this class is not to get some points. The goal of this class is to become a strong and competent mathematician and gain these skills. So if you want to do that, do proofs on these.